Woohoo! We're going to be graphing now today, and it's going to be awesome. All right, so there's a lot of information here. We got some nice little, formulas, general equations for these various graphs here. We're going to be graphing in polar. It's going to be awesome. Look at all these fun little shapes here. These fun designs, right? I remember getting that TI-84 for the first time, and you're like just trying to type things in to make cool looking things. If you switch that bad boy to polar mode, your mind's going to be blown. So we're going to do that here today. I can't wait. I'm sure you can't wait as well. All right, so. Nice little chart here. Feel free to screenshot, jot some things down here. I'm going to go through it as well with some other information below here, okay? So one of the things, cardioid. We're going to start with that one. I know this chart is a little bit different order, but let's start with cardioids. So first off, here's my cardioid. Let me get there's my cardioid graph there. And what we have here is that we want to find the max value of that function. It also always passes through the origin, okay? Always passes through the origin. And you may notice here as well that we've got A and A, they're the same number, but when we get to the limicence, then we've got two different variables, okay? All right. So there's a couple things about cardioids. Then our limicence, right? You need to say it like that. All right. So absolute value of A, when it's larger, there is no loop. When the absolute value of B is the larger one, then there is a loop, okay? Because the A and the B values could be negative, all right? So as you can see here in the limicence, we've got our one with the loop and one without the loop, okay? If there is a loop, then it's going to pass through the origin, right? If there's not a loop, won't. So there are some different things that kind of need to remember, but you'll also be able to work this out with the table of values as well. Because I think it's really hard to remember all these different patterns and things like that. So there's some general things we'll need to remember, but then we'll also use a table of values, our graphing calculators, Desmos, all those things to our advantage to take care of that, okay? Roses we're going to touch on a little bit later, right? It's probably a more complicated one for us to do. We've got ourselves some circles. Let me pop back up here. Our circles, boom. R could be a constant, like just R equals 5. And then we could have R equals a number, some number times sine of x or theta, and same with cosine, okay? We've seen some of those equations already. All right. Let's see if there's anything else we want to get to. Spirals, we'll touch on those a little bit, but not really too much, okay? So let's, without just babbling about all these different things, let's hop into it. Let's get going on our first graph here. We have R equals 6 cosine theta, and that, my friends, is the graph of a circle. All right, so whenever I'm attacking something new here, first off, we did say it was a circle, right? And then whenever I'm attacking something new, I like to maybe take out my graphing calculator, maybe plot some points, things like that. Let's take a look at it in our TI-84. All right, so we got my TI-84 Plus Silver Edition emulator here. Now, the first thing we're going to want to do is we are going to want to switch our mode, okay? So if I click Mode, and I scroll down here, normally we would be in just Function, FUNC. We want to arrow over to Polar. Boom, there we go. All right, I was already in Polar because I was messing with it. Cool. So I've got Polar. Now what I can do is I can hit Y equals, but guess what? Now it's R equals. Go figure. So I can do, let's see here, 6 cosine, and then watch this. When I hit this xt theta n, guess what's going to pop up? Theta. All right. I'm going to zoom standard. There are different ways you can zoom this thing, but I'll zoom standard and look at that. We've got ourselves a circle. Now it kind of looks ovally based on the scaling of this thing. It's rectangular in scale. The x-axis there in our xy coordinate plane is larger spacing than the y-axis would be, okay? So if we're talking symmetry here, what's our symmetry? Well, our symmetry is over that horizontal, that x-axis if we were in rectangular. So we can say x-axis. Okay, what's my diameter going to be? Well, if, again, I pull up this emulator here, we got 1, 2, 3, 4, 5, 6, just like the equation has there of 6. Our diameter is 6. Cool. Now, how about some like a table of values, shall we? I think a table of values would be lovely. Now, if we are, we can use our calculator for that. We can use what we know about trig. I'm going to use some of our wonderfully friendly trig values. Let's do that here with the table. All right, so first thing I'm going to do is I'm going to hit second, and I'm going to do table set. I'm going to start at 0, but then I'm going to also set it to, for the independent variable, I'll set it to ask. That way I can choose what numbers that we're going to put in there. So second table, and now it has nothing there. So how about I use 0? And then let's think about our wonderfully friendly trig values. I could do pi over 2, right, for my different quadrantals. That's usually a good starter. So we get 0. And then when I do, let's do regular old pi, right, because that'd be our next quadrantal. And I've got -6. And then how about 3 pi over 2? 3 pi over 2. There we go. And then if I go back to 2 pi, I've got 6. So we can see here, and think about like what you're going to get for cosine. Cosine is going to be 0 at pi over 2. It's going to be -1 at pi, so on and so forth. And we get our values of 6, 0, -6, 0, and 6. All right, so there we go. We got our table values. Now, one thing you might want to notice is it's r and then theta. Really, we think about that theta first. So those would be my angles, right? And then we get our radius. So we kind of like, it's like backwards from like your x, y table. Okay, cool. So now we can plot these. All right, and when I do plot this, you'll see we got 0 for theta and then 6 for my radius. Then I've got pi over 2 for my theta and then 0 for my radius. So that's right there at the origin. Then I've got pi, but it's -6. So instead of being over here, I have to reflect back, and I'm back to this point here. And then the same goes with the 3 pi over 2 at 0, and then 2 pi over back to 6. So we end up making just this lovely circle, ovally kind of looking thing. All right, there we go. There's a circle. Wonderful. Fantastic. We did our first one. Let's try another. All right, so let's do a little bit of thinking here before we just go right back to the calculator. I think we'll try and do this one by hand. Again, this is a circle equation, right? Circle. Now it's symmetry. For the other one, it was cosine, which was x-axis symmetry. Perhaps we could then infer that the symmetry on this one's going to be y-axis symmetry. Lovely. Now our diameter, there's a 2 out front. It's -2, but that diameter is going to be a positive value. That positive value is going to be 2. Awesome sauce. Now let's use our same values here. I can use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so now if I plug 0 in for sine, right? Sine of 0 is 0, so I get 0. Now sine of pi over 2, that's +1. +1 times -2, I'll do a little bit of work here, and I get -2 for my radius on that one, right? So I'll go ahead and circle that because I'm going to plot that one. And then I can do the same thing for pi and the rest of them. All right. So there we go. We've got, let's see here, 0, 0, so I'll plot that. I got pi over 2 and -2, so if I go up and then I got to reflect back down to here. And then for pi, it's 0, so I'm back at the origin. For 3 pi over 2, which would be all the way down into this guy right here, but it's going to be +2, so I will stay right down here, right? I wouldn't reflect, so that brings me all the way around there. And then 2 pi brings me back to the origin, so we get a little circle there. All right. So that 2 pi just brings you back around full circle, if you will. Okay, moving on. All right, this next one here is a cardioid. Name is cardioid. I can tell by the same numbers, the 4 and the 4, right? They're not different. Okay, with the limaçon, they're going to be different numbers. All right. So my symmetry here, because this is a sine, right? I'm going to have my y-axis symmetry. And then we'll start talking about max and things like that here in just a sec. But how about we plug this one into our graphing calculator since it's the first time we've seen it? All right. So I've got it graphed here, right? I have 4 plus 4 sine theta in there, and now we're ready to rock and roll here. So let's see. What kind of points can we plot here? Again, I'm going to go with my quadrantals, okay, when I'm graphing something new here. Those are generally a pretty safe bet, at least to give me a general picture of things, right? So let's go to our table, and it might actually already give us our, look at that. It's already got them in there, right? The 0, the pi over 2, pi, 3 pi over 2, and 2 pi. And I get this 4, 8, 4, 0, 4. And that's pretty clear from my graph here. Look at that. It's crossing right about 4, okay? Up here, it's 2 shy of the 10, right? So that'd be 8. back over to -4, and then we've got back to the origin. Okay, so let's go ahead and pop those values on our notes. All right, so I've got 48404, and let's take a look at this too, because I think sometimes it's like, well, if I don't have my graphing calculator, I mean, what if you're not always strapped and you got to graph something in polar? We should probably know how to do that by hand too. So if I plug in 0 for theta, I know that sine of 0 is 0, 0 times 4 is 0, and then 0 plus 4 is 4. At pi over 2, sine is going to be 1, and then 1 times 4 is 4, 4 plus 4 is 8, so on and so forth. So we can evaluate using what we know basic stuff about trig functions to get this t-chart. So let's go ahead and plot it. So at theta equals 0, I'm going to get 4. At pi over 2, I'm going to get 8, so I'm a little ways off this thing. That's 7, and then 8 will go right up here. So that means my max over there is going to be at 8, right? So we could put 8 there for my R value. And then let's see where we can even do our ordered pair if we want it. But yeah, let's do R comma theta. Cool. And then we've got pi. It's 4, right? Okay, so at pi, we were at 4. Boom. And then at 3 pi over 2, we're at the origin. We're at 0 for my radius. And then at 2 pi, we're back to 4 where we started. We went, kind of full circle, even though this is not a circle. And it makes this kind of almost like a heart-shaped type of deal. Now, for those of you involved in maybe theater or musical or just playing an instrument and have ever used a microphone, perhaps a Shure SM57 or Shure SM58, not that this is a plug for Shure, but those are common mics that you'll see. They're called cardioid mics. They have a cardioid mic pickup pattern. Now, the majority of the sound, if you know, like if you're holding the mic, right, the majority of the sound's picked up in the front, you're not going to hear people from behind too much. Okay, well, how does that represent? Well, this area is much, I wanted to get the highlighter. Come on, highlighter. There we go. This area is much larger, isn't it, up here, than it is in the back area right here. So you're going to pick up what's in front, that part of the cardioid mic pattern, and in the back, that's showing that it's less audio is being picked up with those little parts there. Okay? Fun fact. You may be like, I don't care, Mr. Allen, but you know what? I care, so I'm going to show you that. Cool? There we go. Awesome. We graphed our first cardioid. Good stuff. Look at that. Now, we have ourselves another. All right. So we got ourselves another cardioid pattern here. So cardioid. Whoa. You're not going to be able to read that. I'll switch colors up. Let's get monotonous. Green. Cardioid. Cool. Now, since this is dealing with cosine here, we know this is going to be x-axis once again. And that -3 cosine theta, that's going to tell us that it's going to be going the other way, right? So it's going to be that negative. Not a parenthesis, but negative. Okay. Cool. I'm not even going to worry about the whole max and min thing actually on this. So let's get to plotting here. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if we're not sure what this really looks like, it could be helpful to fill in a table of values. Well, cosine of 0, that's 1. So -3 times 1 is -3. 3 minus 3 is 0. At pi over 2, cosine is 0. So 3 minus 0 is 3. And then at pi, let's see here, cosine is 0 again. Or sorry, is -1. So 3 times, or -3 times -1 is +3, plus 3 is going to give me 6. All right, good stuff, good stuff. And then at 3 pi over 2, cosine is 0 this time. My apologies for the last one. So I'd get 3 minus 0 is 3, and then back to 2 pi, that's going to be +1 again, so 3 minus 3 is 0. All right, now I can plot these. So 0, 0. I've got pi over 2 and 3, so that's right up here. And then pi, angle of rotation, all the way over to here, and 6. And then 3 pi over 2 and 3. And we see this bit of symmetry, right? And then back to 0 when we're at 2 pi. So now I have this heart shape going that way. Keep it round. Sorry, the third part there, I got a little flat. My apologies. So there we go. Another cardioid. That's awesome stuff. Awesome sauce, as they say. Let's keep it rolling. I'm trying to keep it moving here a little bit so we don't get too lengthy once again with this video. All right. Boom. Uh-oh. Two different values here. So what do we have here? We have a limaçon. Limaçon. Okay, make sure you walk around the house and say that really loud. That's what I would suggest. Okay, so let's go ahead and pop out our graphing calculator once again so we can get a general picture of this. All right, so look at our graph here, and if you remember that if the absolute value of A, that first number, the -3, the absolute value of that is larger than the absolute value of B, which is 2. So 3 is larger than 2. That means we have no loop, and it's very apparent that we have no loop here on our wonderful TI-84 Plus Silver Edition emulator, right? So now, first off, we could say symmetry would be y-axis, right? We knew that just by the fact that it was sine theta, right? Loop, no loop, right? And then we'll deal with our max there in a sec here. We jot that down. We don't have to necessarily. So if I pop this up, get ourselves a table of values. Look at that. I love that. Still plugged in there. Beautiful. So, and we could evaluate this by hand as well. Sine of 0, right, is 0. And so 0 plus -3 is -3. Sine of pi over 2, that's 1. So -3 plus 2 then is -1, so on and so forth. So let's pop that table down on our notes. All right. So now we got to be rather careful with this one here. So we got a lot of negative radii, right? All of them are negative here, so it's going to take a little. We got to concentrate. Okay. So let's see here. At 0, theta being 0, I'm at -3, so I have to reflect back over the pole to get right there. That's negative. That's -3 comma 0. Okay, r comma theta. Now your calculator, if you may have noticed, you're like, wait, why are these numbers backwards? They have theta and then r, which I think is more intuitive to think about it, right? Because we're plugging theta in, but all right, we write the ordered pairs as r comma theta. Let's continue. So at pi over 2, we're at -1, so we're actually reflecting over the pole down here at -1, right? And then let's see here, at pi, we're at -3, so we got to reflect back over to here. And then at 3 pi over 2, which would be down in this area, but because it's -5, we have to reflect back up to here. And then we're, of course, back at home base, if you will. We're at that point. When it's 2 pi, reflect over, we're good to go. All right. So we said there's no loop on this one. And here's what we got. Whee! Lovely, lovely. So it kind of almost looks cardioid-esque, but it's not hitting that origin, right? Not going to that origin. Cool. Awesome. Wonderful. Big thing here, guys, table of values. I can't stress that enough with a lot of these. It's like it's good to remember certain patterns, and that table of values is always something to fall back on when you're not sure what a graph's going to look like. Pick some numbers. Pick some numbers that are favorable. We know the quadrantals are a good way to start. So that's what I would suggest. And it's kind of bothering me that this went to a point. It shouldn't be like a point there. Hold on. Now I feel stressed that I just decided to redo that. There we go. I like it. That's a little better. That's a little more. I like that. Okay. Let's try another one, shall we? Because this one looks a little different. Now we have the absolute value of A, which is 2, is less than the 4. So that means that we are going to have a loop. Yes. So this one, again, limaçon. And our symmetry on this one, well, because it's cosine here, we're going to have our x-axis. I like it. And this one is going in that positive direction, isn't it? Cool, cool, cool. I like it. Woo! Woo! All right, so let's go ahead and get ourselves a nice little table of values here. So I didn't mean to scooch over that much. So we got 0, pi over 2. And if I plug in 0, I'm going to try and do this without the calculator. If I plug in 0 for cosine, cosine's 1. 4 times 1 is 4, so then I'd get 6 here. At pi over 2, cosine is 0. So then 0 plus 2 is going to be 2. All right, and there we go. Got our table of values filled out, just evaluating using what I know about trig and quadrantals. So let's plot some things. Let's do it. So let's see here. We've got 6, 0, right? Or sorry, yeah. So at 0 degrees, got a radius of 6. Then at pi over 2, I'm up at 2. At pi, I have to reflect back over the pole, and I'm at 2 then. And then 3 pi over 2, I'm at 2, and then 2 pi, I'm back to 6. So remember, we said this was a loop, and it does pass through the origin on this one because it has that loop. So we got to be careful how we draw this, right? So it's, let's see if I can get it on the first try. Ooh. I like it. That's pretty good. Should be a little more rounded up front. But overall, pretty dope. All right, I decided to redo it, make it a little more rounded out there. Now I feel good. Okay, so let's actually talk about the max now, like what that means in polar. Because we've graphed these a few times. We've avoided the max here and there. But for our max, that means from the pole. What's the max distance away from the pole? So my max here, not height-wise, but my max from the pole would be at that 6, 0. That's my furthest I am away from the pole. So let's talk about that in this problem here. What's the max that I was away from the pole? That would be at -5, 3 pi over 2 on that one. That was the max that I was away from the pole. Okay? There we go. That's what our max is on that one. I wanted to wait to discuss that a little bit until we started looking at these graphs and be like, well, what does that mean? Sometimes they're turned on the side, sometimes they're straight up and down. What's the max mean in the context of polar? How far it is away from the pole. Okay, so it could be in either direction there. All righty, so I said we were just going to touch on spirals. We're going to use our calculator on this one. So let's go ahead and pop it in there. It's just whoops, I got to turn it on. You know, it saves battery and all. All right, so let's get 1/4 or 0.25 theta, and let's see what we got here. Cool. Right? Wow, that's awesome. I'm going to zoom in a little bit so we can really see this, the spiral action here. Oh, that was dope. Okay, so let's take a look at our table of values here, and then we'll go ahead and plot. So at each of our quadrantals there, I've got some lovely decimals that I can plot. So I'm going to pop those in on the T chart there for us. All right. All right. Spiral. I forgot to write that down. Come on, pen. Sorry about that. It was messing up a little bit there. So we got a spiral. We don't have any symmetry with something like this. Okay, none. So we got none for the symmetry. I don't know why it's not letting me write there when I'm recording, so hopefully it fixes itself. So I got 0. Okay, now we're good. And we got pi over 2, 0.39, which would be right up there. And then we have pi and 0.79, so still less than 1. And then we've got 3 pi over 2, and now we're a little bit bigger than 1, so I'll be a little bigger than 1 there at 1.18. And then at 2 pi, we're at 1.57, so we're a little about 1.5. So my spiral will look like that. How exciting, right? Ugh. There it is. So we're not going to spend too much time with those ones. They're nowhere near as cool to graph. All right, let's keep moving. We got dos mas. Let's do it. All right, so I decided to go ahead and copy and paste some of the information from roses so it's easy for us to see all of it at once here. So we are dealing with a rose. Now our symmetry here, again, it's cosine, so this is going to be x-axis symmetry. Now my length of the leaves. Well, let's look at our notes here. A notates the length of the leaf. So that would be a length of 5. Number of leaves. Now, if B is odd, there are B leaves, and if B is even, there is 2 times B. Well, 4 is an even number, so 2 times 4 equals 8 leaves or petals. Okay, now when we space these, 360 divided by 360 or 2 pi, right, will give us the spacing of our leaves. So let's go ahead and do that. So here we can either do 360 divided by 8. That's what, 45 degrees. Or we could have done 2 pi divided by 8. That gives me pi over 4 spacing. Whether we're in degrees or radians, I think we'll stick with radians since we've been doing that. But we had some degrees up there, so I decided to do that as well. All right, cool, awesome, fantastic, wonderful. All right, so this one's a little more like pattern recognition on this guy here. So first off, where are we going to start with this? Well, since it's cosine, we're going to start on our positive x-axis, okay? If it was a negative a, as you see up here with a negative cosine, with a being negative 0, or sorry, with a being less than 0, so a negative number, then we'd start on the negative x-axis. But because it's cosine, we're going to start on that x-axis there at 5, and then we've already figured everything else out. We're going to go every pi over 4. So pi over 4 would be here, then here, here, here. There we go. All right. So I've got 1, 2, 3, 4, 5, 6, 7, and 8. And now I'm going to go ahead and draw these wonderfully beautiful rose petals. Whee! Well, I messed up. I'm going to pause it. And there we have it, folks. Our first rose. How fun. Graph those in your calculator is pretty cool too, but decided we'll just go with it by hand here. Do a little bit of patterns, some fun stuff there. I love it. Fantastic. Wonderful. Let's do one last one and we'll call it a day. Now we're dealing with sine, and we have ourselves again a rose. So we have a rose. Well, you know what? I'm gonna go red. Red like a rose. Okay. Now my symmetry here, since it's sine, it's gonna be y-axis. And it is positive, right? It's a positive 6. Length of leaves, 6. And if we remember now from the last one, if it's an odd B value, then the number of leaves or number of petals is just that number 5. Okay. So if we got 5 leaves, right, then my spacing of those leaves is going to be either 360 divided by 5 or 2 pi divided by 5. So let's see here. 2 pi over 5. Ugh, that's awful. Let's take a look at 360 divided by 5 as well. All right, so that's 72 degrees. I feel like that's a little bit more manageable as far as like a visual of what the heck's going on, right? Now, with sine here, we have y-axis symmetry. We're going to start up on that y-axis. We're going to start at this point here with a petal of 6. And then we're going to go every 72 degrees, right? So every 72, it's going to land me roughly right about here. And then another 72 would land me right down there at 234. So I'm just keeping track. Let's add 72 again. That would put us at 306. One more. And I think that would be easier to subtract 72 from 90 and put me back at 18. And now I can go ahead and just draw in my wonderful petals. Let's see if I can actually handle myself this time and not, freak out, right? Oh, so far so good. Don't speak too soon, Mr. Allen. I'm talking to myself in third person. Look at that. Love it. Love it. Good stuff. There we are. Rose. Good stuff. Except, wait, did I? Oh no. Pump the brakes. I just realized I accidentally moved to the 5 instead of the 6 on some of these. So let me fix that. All right, so you can see my mistake, my fix. The purple is the correct there, guys. Sorry, I lost track of where I was. I thought I was on the 6 and I was actually on the 5, and I just realized that. So there we go. The purple is the correct. And we had the positioning right, but I was on the wrong radius there. I slipped down to the 5 radius instead of the 6. But that's it. We are done. Have a wonderful day. America, freedom, rock and roll, Costco, and Riverdog Jenny and the Graham. And, of course, Yo-Ro, when applicable. Wasn't the case here. All right. See ya.